Hi students, today we'll discuss about functional groups. So what is functional group? So functional group means a functional group in which in an organic compound, functional group, a functional group in an organic a functional group in an organic compound is an atom or group of atoms bounded together in a unique fashion. So functional group means what? A functional group in an organic compound is an atom or group of atoms bounded together in a unique fashion with the organic compound. Functional group attached to that one, it is unique fashion, which is usually the site which is usually the site of chemical reactivity, So because of this functional group, that organic compound chemical reactivity depends upon this group only. That is known as functional group. So in an organic compound, one functional group, any functional group attached to the organic compound means that entire organic compound property will be changes because of these functional group only. So that only we will call that is a functional group. So reactivity in an organic molecule, if in hydrocarbon or organic compound same, if in a hydrocarbon chain one or more hydrogen atoms, one or more hydrogen atoms are replaced by atoms of other elements. Example, halogens means chlorine, bromine, fluorine, bromine, iodine. That halogens, sulfur, oxygen, nitrogen, etc. So important functional groups we'll discuss now. What is functional group? We know now. Important functional groups. So important functional groups. So important functional groups is first, the functional group is attached to the carbon chain. The functional group attached to functional group is attached to the carbon chain through this valency by replacing one or more hydrogen atoms, replaced by hydrogen atom. So this is a functional group. If it is we are taking formula of okay, some functional groups we will discuss. Formula of functional group. FG means functional group. Then name of functional group. FG means functional group. Formula of the compound containing functional group are example. Then IUPAC name. So these four things is there for every organic compound. So one by one we will discuss. First one example, formula of functional group dash OH. In this dash means R is there, ROH, like R means example I am writing here, then you can understand. Name of the functional group is alcohol. Example is CH3OH. IUPAC name is methanol. How IUPAC nomenclature, how to write name, after I will say. Now one carbon, no, meth. Alcohol means last two letters we should write here, methanol. Methane, instead of E, OL we are writing. Yes, no. Same. One more example we will give so many. CH3 CH2OH. So this is also two carbons, no, ethanol. This is ethanol. So two examples for each we will give. Second functional group is aldehyde. The formula is dash C double bond O, this side H. Here attached to carbon chain, this bond is attached to carbon chain. That example I will say you. This is aldehyde. Example CH3 CHO, like. So this is two carbons is there, CH3 CHO. Ethanol. This is not OL, this is AL, but this is OL. In alcohol OL, this OL only we are writing here for suffix. Yes sir. Here front AL we are writing here. Ethanol means aldehyde. Ethanol means alcohol. Like one more example, CH3 CH2 CHO. Three carbons, no, propanol, like that. Third functional group is ketones, means C double bond O dash. So this side R is there, this side also R is there. Both the sides CH3 groups is there, or methyl groups or ethyl group, whatever it that is there. This is ketone. Ketone, O-N-E, this is ketone. So example, CH3 C double bond O CH3. So like this only is there, no, that side this side CH3 group is there. So now how many carbons total? 3. So we will write this name is propanone, O-N-E, propane generally, but here we are writing propanone. Why we are writing propanone? Why we are writing propanone? This is functional group ketone. That O-N-E we should mention suffix name. Okay, propane, O-N-E, propanone. Here A will come, propanone. Okay, this is name. One more example for this one. CH3 CH2 C double bond O CH3. 1 2 3 4 carbons, no, butanone, like IUPAC name will come. Next, fourth, in CBSE 10th standard, alcohol aldehyde ketone carboxylic acid given C double bond O OH or COOH, like name is carboxylic acid. So example for this one, CH3 COOH, COOH CH3. CH3 COOH means 2 carbons. Ethane, ANE generally, instead of E, oic acid, ethanoic acid. Oic acid is, for this one, carboxylic acid, suffix name is oic acid. So that one I write. So this is the example of this one. One more example also we will take for this one. CH3 CH2 COOH, like is there. So this is functional group attached to the organic compound. Functional group attached to the organic compound. All. This name is ethane after propane. Propanoic acid. Propanoic acid. This is the major functional groups in this chapter. In this chapter, if it is halogen attached, means halogen attached to carbon chain. Halogen attached to carbon chain. For example, CH3 CH2 Cl is there. This name is halogen, no, chloro. Halogen is substituent. This is not functional group, so that only this name front will come. Chloro, halo, no, halo means chlorine, bromine, fluorine, iodine. These and all halogens. Any atom attached here means that atom name only chloroethane, ANE. If it is CH3 Cl means chloromethane, like CH3 CH2 Br means bromoethane. 2 carbons, no, eth, bromine is there, bromo. So this is the name of these compounds. Electron dot structure of 2 compounds I will write now. That is, one is that compound is CH3 C double bond O CH3. Same one more, C2H5OH. C2H5 CHO. Okay, CHO. See, both are same functional, same molecular formula. Here also C carbons 2, carbons 3, hydrogen 6. Here also carbons 3, hydrogen 6, one oxygen, one oxygen. So this is a ketone, this is a aldehyde functional groups. CHO aldehyde, C double bond O, that side, this side methyl group is there, means that is ketone. Okay, in these two dot structures I will write. For first one, this one, hydrogen, carbon, carbon, one more carbon, totally 3 carbons, no? 3 carbons. So this side hydrogen, CHO, C double bond O here will come. So hydrogen, 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 hydrogen. So 3 plus 3, 6 hydrogens, 5 plus 1, 6, 1 oxygen, 3, 2 plus 1, 6 carbon. So this is a dot structure, means here one dot, here one dot, here one dot structure, means valency electrons we have to represent like this. Carbon electrons we are represent red color. If hydrogen electrons we should represent blue. So this is a hydrogen having only one electron, that electron I am representing like this. Oxygen also having 6 electrons valency. See, these two will form helium configuration. These two electrons, these two electrons, sorry, these two electrons. This one also forms 8 electrons like this, octet configuration. Remaining from here like this carbon, like this carbon, like this carbon. Every carbon have 8 electrons is there. Oxygen also 8 electrons is there. Now hydrogen 2 electrons is there. So this is a Lewis dot structures or dot structure of aldehyde and ketone. Ketone also I will write now. Carbon, 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 3 carbons. Here one hydrogen. These carbons attached with one more carbon like this. This is electrons of carbon. So hydrogen electron I want to represent with different color, blue color, like this. We can represent cross or point like also, no problem, dot structure. So this is, now this one will form bond. This one, this electron, this electron, this electron, this electron, and these 2 electrons, this 2 electron, this 2 electron, mutual sharing of their electrons, all are now covalent bonds. Now this carbon having inside 8 electrons, this carbon also having inside 8 electrons, this carbon in this circle 8 electrons is there, count it. So now this is 2 electrons, also 2, this is also 2, this is also 2 electron, this is also 2, this is also 2. This is a ketone, propanone, otherwise IUPAC name propanone, functional group ketone. So IUPAC name is propanone. These two dot structures is this one. Okay, next class we will discuss homologous series, nomenclature of the compounds, few will discuss. Thank you.